we'll take you through it. And we don't actually need to be able to do the whole thing with completing the square. Just like, it's like we're doing like half of it. So I'll get you through like the first couple of examples, and then you guys can go back to the video. I apologize because I have other stuff I have to do other than reteach this class again. All right.
I was like, oh, that can't be fun.
Well, it's better to talk to people than like to myself. Like I shut the doors so that they're like, who's the crazy lady?
Someone walks and they just see you
teaching a lesson to no one, and he just said like the stuffed animal, like Lightning McQueen or something. All right. So our first step is we want to get x squared plus bx all alone. So I'm going to move this 13 away. And this obviously has reasons that we're doing this for later in this section, but right now it's going to seem kind of unnecessary. Now when I do this, I'm actually going to leave a little space there. If you didn't, it's okay, but because we're going to put some data in there. So the point of this, completing the square, works when you can't factor. And you could do quadratic formula to solve this, but completing the square is kind of bypassing the quadratic formula. And what we're trying to do with this is we're trying to make it factorable. So I'm trying to put something in there that will be able to be factored. So the way we find that number is I do b divided by 2 squared. So I take that negative 8, I'm going to divide it by 2 and then square it. So I get negative 4 divided by 2, or sorry, negative 4 squared is 16. So I'm going to put that in here. So that 16 came from negative 8 divided by 2 squared. Now if I do that to one side, to balance my equation, I have to do it to the other. So I'm going to add that to both sides. Now why this is good is because now this becomes factorable, and this will always work if I use that b divided by 2 squared. So this becomes x times x multiplied as 16 but add to negative 8, negative 4. And it'll always be the same thing twice. So this will always be able to be written this way, hence the name completing the square. So it's a perfect square every time. So that's going to be our step 3, is to factor that. So it's always going to be the same thing twice. Now technically this is all we need to be able to do with completing the square today. So I'm actually going to stop for time's sake. But if we actually wanted to solve this, then we can go take the square root of each side, and then it'd look a lot like the quadratic formula. So this again is an alternate way of doing, like not having to do the quadratic formula. But this is all we need for today, so that's what we're going to do with the second one, just to practice it. So again, first step, we'll move that 20 over, get that out of the way. And when you guys go to watch the third video today, it's gonna like relate really closely back to this, and always feel free to pop in for questions, because I have this hour off. I just have to get some stuff together. Here, start there. So leave a little space. So my b divided by 2 squared, so 6 divided by 2 is 3, and then squared will be 9. Again, that always will be factorable as a perfect square. So you can do the double parentheses, or you can just go right to single ones, because multiply to get 9, add to get 6 is 3 and 3. I think the nice part about this is it's always nice to factor, because it's always really nice numbers, and there's never a number in front of x squared. Completing the square doesn't work if I put a number in front of x squared. So we need this for our last 2 problems today. And again, if it doesn't make sense, feel free to come in. So we're gonna graph circles here. And our equation of our circle is gonna look familiar to you. There's a few, like it's gonna look similar to like distance formula and slope, that they all have connections, so this isn't a coincidence. So this is my equation of a circle. Now if you think about a circle, a really important point on a circle is, or like thing to know, is the radius of a circle. So r is obviously going to be the radius. And notice in the formula it's r squared. So it's always going to show up like bigger than the radius because you have to take the square root to figure out the radius. So like down here, it's not 16 is the radius, 4 is going to be the radius. So like you'll have to do a step with that. Another really important point of the circle is the center. And that's what the H and K stand for. So H and K are the center of this circle. So if I know the center and the radius, I should be able to graph my circle. Now, if you look at it, and then the X and Y are just points on the circle. So there's lots of them. Now the tough part of this formula is the H and K, they have minus signs in front of them, and that's intentional, and that's because of the way the formula works. But for us to find our center, it's kind of like, it looks like the opposite signs. So I'm gonna kind of write that here, and we'll talk about that down in this example.